Geological connect the dots. Today we're going to relate plate tectonics to the formation of crustal. So we're going to collectively connect the dots. So we're going to connect this dot to this dot. And what are we going to do? We're going to identify the boundary and geological feature located at the end of each line segment. So looking here, we would talk about the boundary and the geological features represented here. Then we're going to work collaboratively to identify the types of crust, the motion, and the process that occurs at each boundary. Then on the inside of each line segment, we're going to talk about similarities, and then on the outside of the line segment, these yellow blocks, we're going to talk about the differences between the two boundaries at each line segment. So let's start. Let's try to work through 1 through 4 together. So first we're going to, let's start with this one. We'll identify the boundary and the geological feature. So here, the first thing you want to do is look at the arrows. That's going to indicate the motion. So you see 2 arrows coming together. So we can identify this boundary as a convergent boundary because they are converging or colliding. Okay, and then we could talk about the crustal features here. So here it looks like we have an oceanic crust converging with a continental crust. So your crustal formations you can see here are going to be volcanic mountains like the Andes in South America. Your process that takes place here is called subduction. So you can see this oceanic plate going underneath the continental plate because it's more dense. In this case, you would always get trenches when oceans are involved. Okay, so I think we did well with part 1 and 2. We named the boundary, the geological feature. We talked about the type of crust, the motion, and the processes. Now, we are going to talk about similarities between 2 boundary interactions and then differences. So in order to do that, we're going to have to look at this next plate boundary. Okay, so we can kind of save 3 and 4 once we talk about another boundary. So here, let's discuss this boundary. Here we have arrows moving away from each other, so that would be a divergent boundary because they're breaking apart. And it depends on what type of crusts are involved. If this is a continental, we're going to get a rift valley. If it's oceanic, you're going to get a mid-ocean ridge. Okay, so now we can talk about similarities and we can talk about differences. So here, if we wanted to talk about similarities between these 2 boundaries, I don't necessarily see similarities besides them both being boundaries and different crusts are involved. Similarities, they're both making crustal formations, etc. So probably part 3 and 4 would be the most challenging to talk about similarities and differences because these boundaries seem to be just the opposite. These are converging, coming together. These are divergent, moving away. Okay, let's go over to this line segment here now, and it's bringing us over to this boundary. So here, what you want to look for first are the arrows, and you see these 2 arrows coming together. So we can say it's converging, and it looks like an oceanic converging, and you have one oceanic that's older subducting underneath the newer crust. And what happens is that older crust melts in the mantle, pushes magma up, and you're going to get volcanic island arcs like the Aleutian Islands in Alaska. Now, if we take this segment and we move up here to this boundary, Looking at this plate boundary, you have converging happening here because the arrows are coming together. So here we have a continental crust converging, and you're having mountain formation, folded mountains like the Himalayas mountain range. So perhaps now we can look at similarities and differences when we go over here and we look at these two boundaries. They're similar because they're both converging boundaries. They're coming together, and you can see that with the arrow movement. But here you have continental forming mountains. Here you have oceanic continental converging. So you're going to get different crustal formations. Over here too as well, this is converging. So these two, all three of these would be similar because they're converging, but here you have oceanic, which is always going to give you trenches, and you have those volcanic island arcs. Okay, moving to the next slide, we're going to do the same thing. We're going to look at these plate boundaries and then look for similarities and differences at the end. So here, arrows are coming together. That's converging. So we have continental, and we're getting mountain formation, folded mountains like the Himalayas. If we go over here, this here too, you have arrows coming together. And let's see, oceanic crust, continental crust. So the oceanic crust is subducting underneath the continental crust. It melts in the mantle, pushes magma up, and it makes volcanic mountains along the coastline of the continent, like the Andes Mountains. Okay, and then coming down here, we can see at this plate boundary, your arrows are sliding past each other, and you would have a fault. So here we have an oceanic crust sliding past a continental crust, and a great example would be the San Andreas Fault in California. And then going over to the end of this line segment over here, you have arrows moving away, so we call that diverging, and it depends on what type of crust is diverging. If it's oceanic, we're going to get mid-ocean ridges. If it's continental, you're going to get a rift. Okay, so now we could look for similarities and differences. So here we can see that 1, 2, 3, these three plate boundaries are up. These two plate boundaries are converging. They're coming together. Okay, and they make different crustal formations. Here, this boundary, since it's sliding past, it's a transform boundary, which is different from all the other ones that we have here, as well as this boundary over here being a divergent boundary. Okay. Going to our next slide, I would like that you guys identify 10 words related to plate tectonics and use those 10 words to write a summary of what you've learned. So you can just list your 10 words. So maybe you want to list something like the type of boundaries, converging, diverging, transform. You can talk about different crusts, crustal formations. You can talk about subduction, mountains, earthquakes, trenches, etc. And just write a brief summary of what you learned using those words. You don't have to use all 10 words in your summary. Okay, just list words that come to mind and summarize for me what you've learned in plate tectonics. A brain dump strategy. This is always a good strategy to use. So I'm going to click on this link here, and it's going to bring us to a little brain dump. And this is something that you can do just using a piece of paper and a pencil, and you can write your own little brain dump when you're taking tests on your paper. So let's look.
All the strategies we talk about here, you're going to do all.
Okay, and I'm just going to skip forward to where we want to be. Let's see. All right about here, where we talk about plate tectonics.
Northern Hemisphere. In the bottom left quadrant, we're going to talk about plate boundaries or plate tectonics. There are several different types of plate boundaries. The first one we're going to talk about is convergent boundaries. And convergent boundaries are when two plates collide together and they create mountains. Generally, when two continental plates collide together, they create a mountain chain. Now, they can also, if one is more dense than the other, they create a subduction zone. Generally, what happens is an oceanic plate goes underneath a continental plate, and it creates trenches. And the geological formation that is created on the backside of the continental plate is a volcano. Next, we have plates that are going apart from each other or diverging. Those are called divergent, or that's called a divergent plate boundary. And when two continental plates diverge, they create rift valleys. And when two oceanic plates diverge, they create mid-ocean ridges. And then lastly, if plates are sliding by each other, these are called transform plate boundaries. And these plate boundaries, when they slide past each other, create earthquakes. Lastly, we're going to talk about some life sciences in this bottom right-hand.
Okay, so that was called the brain dump strategy. And what you can do here is you can grab web paint and you can draw here the same thing that he did in this yellow box. And if you don't know how to use your drawing tool, you can just type to me your 3 types of boundaries and describe them. Okay, and then lastly today, there's interactive activities for you here. So you're going to click on this blue link here, and this guy here is going to set you through a few games to review, and there's a little quiz for practice at the end. Of course, there's no grade involved. This is only for practice. So I'm just going to click on it and walk you guys through a little bit of it, and that will be the end of today's lesson. So let's see what we have here for an interactivity. So here it says this is a 2-part challenge. First, you must correctly place the names of the major tectonic plates on the map, and then you must identify the type of boundary that's found at the borders between several of these plates. Okay, so we're going to drag each plate and name it to the correct location on the map, and let's begin. So I like to start with the plates that I know first. So if I drag the African plate, I know where Africa is. So that's going to help me out with identifying this plate. Okay, and I'm just going to scroll and go through some of the ones that I know. So for example, the North American plate where we live, I'm going to drag that up here. Okay, and I've correctly identified it here. Okay, these other ones, Pacific plate, you guys understand that the Pacific Ocean is over here next to us. So just drag and drop those plates and he will take you through some other interactive games. And then again, there's a little quiz for practice for you guys at the end of that. So have fun doing that. And this is a little practice for tomorrow's test that you guys have, okay? So I hope that was helpful, and you all have a